Hey everyone. In the previous part, I ran out of board space with the proof that I was doing, and so I thought I would continue the proof with a brand new blackboard or whiteboard. And this time I'm going to allow myself plenty of board space so that the board is just not clogged up with clutter and the proof is just impossible to follow. I'll try to make the proof as visual as I can. Now, if you remember, we're trying to show that in a group, an element X cannot appear in any row or any column more than once. And so we're going to prove the case that X cannot appear in any row of a table more than once. And the proof for columns is similar. So here we go. Suppose, for the sake of deriving a contradiction, that X appears more than once in a given row. For example, let's say that X appears twice in the row headed by the element little g. Now, if that's the case, then there exist elements A and B in the group, such that in the row headed by G, X appears in the columns headed by A and by B. Let's draw a picture of what this would look like. That we have our group. We have the identity. And then somewhere in the group, there's a column headed by A. And somewhere in the group table, there's a row headed by A. And somewhere in the group, there's a column headed by the element B. And somewhere in the group table, there's a row headed by the element B. Except I guess I really don't need this. I really don't need this. According to what we have, X appears twice in the row headed by the element G. So we're interested in some row that's headed by the element G. And here in this row, X appears twice. Now we'll fill in part of the group table. Okay. And this is really all we need. And let's look at what this group table is telling us. Take a look at this element X right here that appears in the row headed by G and in the column headed by A. The fact that this element X appears in the row headed by G and in the column headed by A tells us something. Let's write down what it tells us. Isn't that what it tells us? G star A equals X. That's what it tells us. The fact that this element appears in the row headed by G and in the column headed by B tells us something as well. It says G star B equals X. So let's write that down. Everything's the same right now as it was in the remainder of the proof that I am telling you to ignore. I am now going to erase most of the board to make room for what I need to write so that I can write it in a fashion where visually we get the point and there's not so much clutter on the board that we lose everything. Okay, I wrote down the important things that we need to work with. Now, before I do anything with either of these equations, let me remind you of something. G is a group, right? So, because G is a group, the element G has an inverse. We'll denote it this way. So let's take the first equation. G star A equals X. I'm going to multiply both sides by the inverse of G. And then by associativity, I can choose to associate these two elements first. Whoops. And I'll write down here that this happens by associativity. And that shouldn't be an equal sign, should it? This should be implies. Okay, I like that a lot better. This equation implies this equation. All we did was we changed the elements that we associated together first. And by associativity, we can do this. But what is G inverse star G? It's got to be the identity, right? That's what happens when we multiply an element by its inverse. So we have E star A is equal to G inverse star X But what is the identity star A? Isn't that just the element A itself? So we have A equals G inverse star X. Now, let's work with the other equation, G star B equals X. And I better allow myself some room here. G star B equals X. And again, I'm going to multiply both sides of the equation by the inverse of G. And we pull the associativity trick again. So we can change the pair of elements that we associate together first. And an element star, its inverse, is just the identity. Whoops. E star B equals G inverse star X. And what happens when we multiply an element by the identity? We just get that element, right? So we have B equals G inverse star X. And what we really want to focus in on is the tail end of each line. That's what we want to get. A equals G inverse star X. B equals G inverse star X. So we come to the conclusion that A equals B. And is that a problem? Yes, it is, but it's a problem we're glad to have because we're doing a proof by contradiction. A equals B, that's a problem. It's a problem that we're delighted to have because we're doing a proof by contradiction. We want something to go wrong, and this is what went wrong. We arrive at the conclusion that A and B are equal, but this contradicts the fact that A and B are distinct elements of G. Well, how do we know that? Because A and B had two distinct columns of G. So as the headers of, or the elements that had distinct columns of G, they have to be two distinct elements. So where does that leave us? Well, let me write down the conclusion of this part of the proof. So here's how we conclude this part of the proof. We want to make sure we understand what it was that caused the contradiction. Since the assumption that X appears twice in a row of the group table leads to a contradiction, the assumption must be false. Hence, an element X of G can appear at most once in any row of the group table. There we go. Now that's only half of the proof. The other half of a proof requires that we show that X must appear at least once in every row and every column of the group table. And we do that next. Here's the rest of the proof. An element X and G must appear at least once in every row and in every column of the group table for G. Now, we'll note that we'll prove that X must appear at least once in every row of the group table, and the proof showing that X appears at least once in every column is analogous. So we'll show that X has to appear in every row at least once. We're not going to show that X has to appear in every column. The details are essentially the same. So, here we go. Let G be a random element of set G. And we have to show that X appears in the row headed by G. Well, let's draw a picture of what that looks like. Let's look at the group table, and we'll focus in on the row headed by the element little g. So we have a picture of what this looks like. We're showing that the element X appears in the row headed by the element G. So here's the group table. Here's the row headed by the element G. And we're saying that somewhere in this row, the element X has to appear. So somewhere in this row, we're saying that the element X has to appear. So X appears in the row headed by element G. And it has to appear in some column also. So we'll say that this column is headed by the element H. So what does this mean? Well, let's take a look at what this element X is. If it appears in the row headed by G and in the column headed by H, what this means is that G star H equals X. That's what it means. So what we're claiming is given an element little g in the set G, there exists an element h in the set G such that G star H equals X. To say that X appears in the row headed by G means that there exists an element H in the set G such that G star H equals X. So the question that we have to answer is, does such an element H exist? If we can answer that in the affirmative, then we've completed this proof. So this is the $64 billion question. Does there exist an element H in the set G such that G star H equals X? Well, let's look at that equation. Because this is a group, the element G has an inverse. So we multiply both sides of this equation by the inverse of G. And then we use associativity to associate these two elements together. First, and G inverse star G is just the identity. And the identity star anything is that thing. So this gives us and forgive me, I've been leaving something out here. I multiplied both sides of this equation by G inverse. So this should be G star X. This should be G star X. This should be G star X. Is H an element of G? Absolutely. Because the binary operation on the elements of the set G is closed on the set G. That's one of the group axioms. Here we're answering our question. Does there exist an element H of G such that G star H equals X? And we claim this is what H is. So we'll take G star H and H is G inverse star X. And by associativity, we'll associate these two elements together first. And G star G inverse is just the identity. And so there we have it. G star H equals X. Now, what did all of this mean? Given an element little g in set G, the element X appears in the row headed by G. And in the column headed by H, where H equals G inverse star X. So that's our proof, probably in more detail than we needed to show. But what it tells us is that in every group table, every element of the group appears exactly once in every row and in every column of the group. No more than once, no less than once.